So a dilation, we should know, changes the size of a figure. The most recent Regents questions, when they ask about dilations, are actually centering at the vertex. We actually should like these because it actually makes it a lot easier for us to do a dilation, and I'll show you why. So when we're doing a dilation centered at a vertex, so for this example, I'm saying dilate the triangle by a scale factor of 2 centered at A. So I'm first putting my compass centered at vertex A, and I'm going to measure the distance of AB. So I open my compass and move it until I'm over B, and I'm going to swing an arc to get that measurement. I now want to copy that segment at the ends because I'm basically going to be doubling the size of this triangle by copying that segment. So this is not the length of AB. I just drew a generic line so that way we will have enough distance to cut. So using that same distance from the first part, I am going to swing another distance, and now this will be B prime. So A to B is here, so AB prime is twice the distance of AB. So I'm just going to repeat that process here. So now we have B prime. So what you should remember when it comes to dilations is that the segments are going to change, but the angles are not, right? And this is why I said when we center at a vertex, it's nice because this angle is not going to change. It's going to stay the same. And since I'm centering it here, A is the same as A prime, so I don't have to construct this angle. I do have to copy angle B over here to get the correct sort of angle measurement. So we're going to have to copy the angle. So you start at B, move your compass down, right? We're working with a smaller triangle, so you want to try to keep things smaller if possible. So you first make an arc, and then you move your compass over. Whatever you do to one, you should do to the other. And now I need to know at what distance, right, is the line opening up. So I'm going to mark my intersection points here just to make it easier. I'll start at the bottom one and see the distance from the bottom X to the top. So right about here. And you're going to repeat that. So here we have the bottom X. You need to construct the top X. So I'm just going to double check, make sure. And so now we're going to connect B prime and our X. So now these two angles are congruent. Now the last point that I have to construct is C, right? So in order to construct C, you're going to extend the segments you already have. So you already have the beginning of B prime, C prime, and you already have the beginning of A prime, C prime. You're basically going to want to extend those lines until you hit an intersection point. So I'm going to set this up. First, I will set it up to see the same stuff that we have on the other side. So first step, again, copy your segment at the bottom. And so this is with a dilation of a scale factor of 2, which is why I only have to do it once. If I was going to do a dilation of a scale factor of 3 or 4, that would tell me how many times I have to copy my bottom segment, right? But because this is only 2, 1, 2, I only have to do it once. It's a good example. And for the most part, the geometry regions is not usually going to give you more than 3, or they could also give you something smaller. So they could give you a dilation of a half, in which case you would just want to be taking the you would want to bisect the segment. I have another video showing you guys how to do that. So all I'm doing here right now is just repeating the same steps that we had done on the first page, just here. So that way it looks the same. Again, you would not have to redo this. I'm just doing this because this is the way the notes are set up. So again, you're not overwhelmed with just seeing a whole construction at once. So now all we have to do to get C prime. So I've already extended A, B prime out. I'm going to extend the line from A, and you can see that there is an intersection point here, which is C prime. So that's all we have to do to dilate a figure centered at a vertex. You're copying the segment, copy the angles, extend to intersection.